All right, ladies and gentlemen, it is not November 5th, September 5th, Wednesday. Look at the pattern. Tell me what you see. Describe and label the pattern. Go. Whatever you add the first time, you got to do that twice. Well, let's just kind of do some things. So that's 3, right? How many's here? 6. How many's here? How many's here? How many's here? 48. All right. So first train of thought is you need to know what your totals are, right? Right. In the beginning or at the beginning, what does that mean? Stage what? 0. That's exactly right. That's stage 0. This is what? 2, 3, and what? All right, ladies and gentlemen. Do a table. Okay? Do a table. You'll see a lot of things if you will. Okay? Now, is there a common difference? Yes or no? Huh? Yes or no, folks? Is there a common difference? Yeah? There's a common difference? So, huh? A common difference means it's changing by the same amount every time, whether that's a positive or a... Okay. So, is there a common difference? Huh? No. No. It's not going up by some same amount or down by same amount every time, is it? I mean, look. Let's look at it. These are changing by how much? 3, and now it's changing by what? 6, and now it's changing by what? Yeah, man, this thing right here is like, geez, there ain't no common difference on that, is there? So it's not what type of sequence? It's not arithmetic, right? Arithmetic. Repeat after me, arithmetic. There you go. See, if I can pronounce it, you can too. What? What do you mean put them over each other? What do you mean? Well, we can. I mean, I could say changing X, here's changing Y, right? All of these are changed by 1s, right? When you're changing X as 1, then you're really looking at only you're changing what? Y, right? Okay? But it's not the same. So it's not arithmetic. So it's not a linear, right? Progression. So, what you're going to get introduced to today is called geometric. Okay? Geometric is a big old word for exponential. Alright? So, you've already been exposed to exponentials. Did you know that? You've been exposed to exponentials ever since you were a wee little lad. Have you ever taken any medicine? Ever in your life? Have you ever taken any medicine in your life? When you put it in your body, it's at a certain level, right? All right, what happens over time? It works, then it says what? Okay, I'm done. That means your body starts to do what? Anything you ingest in your body, what does your body do? It gets rid of it, right? Correct? So once you ingest that medicine in your body, it starts to decay, right? Now, so things go down. That's why they say take an aspirin every so often, right? That ever so often is to make sure that you maintain a certain level of that particular medicine in your body. Not too high so that it has adverse effects for you, and not too low that it's not beneficial. Do you understand? Now, how many of y'all touched that door frame or grabbed the door or touched something, your desk or whatnot when you came in? That would be everybody. Okay. Now, what's on all that stuff? Germs. Excellent. Now, how do germs reproduce? Well, I don't know. It could be double. It could be triplet. Germs or bacteria grows, right? Now, it doesn't grow at a constant rate, does it? No. Because it would take you like weeks before you feel really, really, really bad, right? What happens when a bug, so to speak, jumps on you? Man, it takes you down in less than what? 24 hours, doesn't it? Yeah? Like you get over a bug, whatever the bug is, a flu bug, stomach bug, it will take you out within 24 hours, right? Yeah. So, bacteria in your body grows at an exponential rate. Okay? So you've already been exposed to exponential equations, or things are exponential. Population grows exponentially. Rumors spread exponentially. Woo! Oh, no, he didn't. Yes, he did. The old rumor mill spreads exponentially. Right? You ever saw that commercial where one person tells two people tell two more people, those two more people tell two more, and all of a sudden you got like what? It just like shoo, goes, right? All them people tell another, man, that sucker's just taking off, isn't it? So what we're going to do is we're going to look at exponentials, better known as geometric, for sequences. Okay? They have a common, what is considered to be a common, here you go, not a common difference. A common ratio. We call it a multiplier, right? We'll call it a multiplier. A common ratio or a multiplier. How is something getting to the next thing? So if we know that this particular table or these dot patterns are not going up by the same amount, a common difference, right? Then we can also look at it in terms of, you ready? This is pretty cool. You take the next one divided by the previous one. So let's take 6 divided by 3. What do I get? Oh, there's a common ratio of 2. 12 divided by 6. What is it? Oh, 2. 24 divided by 12. Oh, 2. 48 divided by 24. Oh, so my common ratio is what? 2. All right? In exponentials, we call that the base. We call that the base, right? That's, like 2 squared, 2 cubed, all that stuff. You remember all that, right? Yeah, all the exponent stuff. There's base and there's exponents, right? Yeah. So, now, it's going up by a common ratio of 2. We can now predict what the next numbers are going to be, aren't we? But what if I said, you know what? 180th dot pattern. How many is that going to be in it? What do you mean we're not going to be able to calculate that? Oh, no, we do not want to count that. You're exactly correct. Yeah, I mean, dot. Yeah, no. You don't want to do that, do you? So, let's look at it. So, that's linear, right? So, let's look at it if it is called geometric. Now, geometric has 2 forms of equations. What do you think they are? Huh? Explicit form, shocker, and what? Lord help me Jesus. Yep. And cursive. Huh? You seen that before? No? You haven't? Okay. I was like, what rock is he being hiding under? We'll check your attendance. Okay, so explicit. You ready? It's right over there. Right here. See this right here? Right here. Right there. Okay, you ready? So, A sub n equals A sub 1 times R raised to the n minus what? Make that sure that's an n. Yeah? Well, that's cool. That's cool right there. I don't care what y'all. Yeah, that's in first term. How do I know that's in first term? You are kidding me. What would it look like if it's in zero term? Oh man, let me show you. This is good right here. Ready? I like the little thing like that. See the difference? We have R raised to the n and A sub 0 for zero term, and for A1 or first term, it's A1 and it's R raised to the n minus 1. Okay. Now, if I do recursive, and we are, then big old shocker. You ready? This is cool. Ready? Right. That's a subscript, right? Subscript means it goes below it, right? Yeah. This is pretty cool. Watch this. On the arithmetic, it was plus D, right? But for geometric, which is exponential, it'll be times R. Didn't I take the previous? Oh, let's look. This is cool. This is cool. Huh? What? Common ratio. Common ratio. Girl, you good. I don't care. Now, if I want to use the recursive, which says the previous one times the common difference, not common difference, common what? Ratio. So let's take 6, that's the previous one, to find the second term. So 6 times 2 is who? If I want the next one, 12 times 2 is who? I want the next one, 24 times 2 is what? See, that's recursive. I got to have the previous one in order to get to the next one, right? Correct? See, the explicit form will allow me to go to wherever I want to go. Wherever I want to go. So, with that being said, I need you to look at said paper, and I need for you to fill it out. Ready? Giving you, I don't know, 2 minutes. Go. Okay, guys. Assuming that the sequence continues in the same way, how many dots are there in 5 minutes? All right, so how did you get 96? Huh? All right, so 48 times 2. Well, okay, you can do it a couple ways. 48 times 2 because, you know, the fourth one's at 48. The fifth one better be 48 times 2, which is 96. But let's just see, for grins and giggles. What was A1? Huh? You sure? So let's see if we can, I wrote the explicit form, right? Do y'all agree or concur with what I've got? Yeah? Well, it said, assuming the sequence continues, how many dots are there in 5 minutes? Okay, well, I can skin this how many different ways I want to, right? So let me camp out and nerd out. All right? Yeah. Huh? Why would I use the explicit form of any sequence? Anybody? It is the easiest. Why is it the easiest? Because it's wrote easy underneath it, right? When you go up to the shelf and you pull off the explicit form of anything, it says easy right underneath it, right? No. What does the explicit allow me to do? I heard it here, but I heard it here starting first. Go. You can use it to find any term. Well said. Well said. Now, y'all ready? So, we're on the fifth term, right? So, a sub what? Equals 6 times 2 raised to the 5 minus 1, right? Yeah? Okay, what's 5 minus 1? What's 5 minus 1? Come on. 4. Good. I was beginning to wonder if we need an abacus. We need an abacus? No? Those little things, those little beads on it, roll it out, you know. Yeah, yeah. Uh-huh. Now, what is 2 raised to the 4th power? 16 times 6. What's 16 times 6? How much? So A5 is 96. Okay. What does 48 times 2 mimic? What does 48 times 2 mimic? Anybody? Nope. Huh? What does 48 times 2 mimic? Because it is 96. It's the what? It's the recursive. Why is it the recursive? We're taking the previous one times the who? Common ratio. I love it. It's great. Smile. Y'all have had 4 days off without having to see this ugly mug. So you ought to be really, really, really happy. Well, some of y'all saw it. Sorry if you had to. Now, write a recursive formula to describe how many dots will be there after t minutes. You ready? Recursive? Anybody? A sub n equals A sub n minus 1. Hello, that is what? What do I call that? Rubber stamp. Why do I call that a rubber stamp? It's always there. It doesn't change. We're not putting 5 minus 1 here, are we? No, no, no. We are if we want to find the 5th term or 4th term, right? Yeah, when I'm evaluating, but for a general equation, that's it. Done. Bada bing, bada boom. What you think now? Easy, right? That's all relevant, right? Easy is all relevant to the person that's learning. You ready? Learned it? You're like dead. I gave you 4 days off. That's sad. Write the explicit formula. So talk to me. I got A sub n. That's first one. What did I do? 6 times 2 raised to the n minus what? All right. That's in terms of what? First term. Now, if I want to get nerdy, and I love to get nerdy. Yeah, man. Okay. I want to know. You want some cheese with that wine? Because you're whining. I bet you go on vacation on Winnebago. That's pretty cool right there. All right, so what goes first? What is the A0 term? Yeah, what's the 0 term? How'd you get that? In the beginning. In the beginning, right? 3 or at. Okay, at. That's the preposition. Lord help me. Now, for grins and giggles, huh? What do you mean? The black or the red? Why? Uh-huh. It said, uh-huh. After. Uh-huh. All right. It's explicit form. It's the explicit formula in terms of 0. How do I know it's That's right. That's exactly right. See, the explicit. The explicit means no matter when, right? It will get you to no matter what. Well, if you got the black one, you got to at least have the black one. What's the red one? I'm just nerding out, Anna. So for grins and giggles, let's check the first term. Y'all ready? So if I do 1 minus 1, that's what? What's 2 raised to 0? No. Anything raised to 0 power is 1. What's 6 times 1? So it's the first term 6. Yes, it is. Let's look at this. Okay, hold up. What's 2 raised to the first power? 2. What's 2 times 3? Okay, so we validated that both of them give us the same outputs, right? Questions? Okay. Most of the time, you will write the explicit form in terms of A1, and only A1. But there'll be times when you'll have to write it in terms of A0. Here's the question. What if I only give you the first term and a common ratio? Could you find what the 0 term is if I said write it in terms of 0? How so? Oh, instead of multiply by 2, take the first term and do what? That's exactly right. What's 6 divided by 2? Well, how about them taters? I know. I will in a minute. It's right. What's the deal? Oh, that one's wrong. That one's wrong, bro. Because that's A1, not A sub n. That's A1 right there. Yeah, you do. We just wrote them down right there. I know, but I don't know. You know, but you don't know? You know? I don't know. Ladies and gentlemen, that is all that I have for introduction to geometric sequences. Now, we're going to do some homework. Yeah, you do.